Today, we will continue to discuss the ulangan paper of STPM Past Year in 2020, Section B. A sphere X of radius 0.15 cm is fixed at a distance of 0.5 meter from sphere Y of radius 0.3 cm. The charges on X and Y are positive 3 and negative 2 microcoulomb. So first is to determine the force between X and Y. So we have Coulomb's law, and the formula is equal to the product of charges, which are given in the question, divided by the 4 pi epsilon r squared. So you should obtain the answer as 0.22 Newton in A. Next, we're going to explain what happened to the charges when X and Y are connected by a thin wire. So when X and Y are connected, so what you can expect is the charge are free to move between X and Y. So we have positive and negative charge. So since X has a higher magnitude of charge, it will neutralize the negative charge on Y, and the remaining charge will continue to charge Y until both of them have the same electric potential. So what we mentioned about the electric potential is that the flow of charge is related to the flow of current. And we learned that the current always flows from the higher potential to the lower potential. So if both of them have the same electric potential, the charge will stop to move. Now we're going to solve the second question is when the thin wire is removed, determine the final charge on Y. So based on the explanation, the remaining charge will be equal to 1 microcoulomb, that we have 3 minus 2. And then they will perform the charge distribution until the electric potential at X is equal to electric potential at Y. So we're going to use the formula of electric potential as Q over 4 pi epsilon, where the radius of X is 0.15 centimeter and the radius of Y is 0.3 centimeter. And from here, we can obtain the ratio of the charge of X and Y, where the charge of X divided by the charge of Y will be equal to 1 over 2. Okay, we have the 0.15 divided by 0.3. And from here, we can apply the knowledge of the ratio, where the charge of charge of Y divided by the charge total will be equal to the 2 to 1 plus 2 is 3. So this is how we can use the knowledge of the ratio. And from here, what we can do is that the charge of Y is equal to 2 over 3 multiplied the remaining charge, 1 microcoulomb. So it is equal to 0.67 microcoulomb. So that will be the final charge on Y. So proceed to question 17. A resistor of resistance 50 ohm and an inductor of inductance 0.2 Henry are connected in series with a sinusoidal source V equal to 240 multiplied sine 120t. So the 120 here should be referred as the angular frequency. So first is to state the phase relation between current and voltage across the inductor. So simple, the voltage across the inductor is leading the current by 90 degrees. So calculate the impedance of the circuit. So first is we need to calculate the reactance of the inductor, where the formula is the omega L. So we have the angular frequency as 120, multiply the inductance 0.2 Henry. So you will have 24 ohm. And then we're going to apply the formula of the impedance, where the square root of resistance 50 square plus the reactance square. So we have 55.5 ohm for the impedance. And we're going to move to section C. Capacitor consists of 2 square parallel plates separated at a distance 1 millimeter. Each side is 5 centimeters, so this is where you can get the area of the plates. Magnitude of the electric field between the plates is 5 times 10 to the power 4 Newton per Coulomb, and the potential difference between the plates is 10. First is to sketch a diagram to show the electric field lines in the region between the plates. So it's quite simple. So remember to specify the positive and the negative terminal, so that the electric field always flows from the positive to the negative terminal of the plates. Next is to calculate the potential difference between the plates. So simple, we have the formula of V equal to ED. So electric field strength is 5 times 10 to the power 4. Multiply the distance separation, which is 1 millimeter. So it is equal to 50 volt per meter. So now the next question is to calculate the energy stored in the capacitor. So we have the formula of half CV squared, or half QB, or half Q squared over C. We don't have the charge, so probably we can find out the capacitance. Because we have the distance separation and also the area of the plates, So capacitance can be obtained by the formula of epsilon A over D, where the energy can be re-expressed as half multiply the formula of the capacitance, the permittivity, multiply the area over the separation distance, multiply V squared. So all the values can be obtained. So what we have is 1 over 2, multiply the capacitance, where we have the permittivity, multiply the area of the base, which is square. So we have 5 times 5 centimeter. So it is equal to 25 to the power times 10 power of -4 divided by the distance, 1 millimeter. And then we multiply the square of the voltage, 50 square. So in the end, the energies that can be stored in the capacitor is 2.77 times 10 to the power of 8, -8 joule. Now we move on to question B. Capacitor is fully charged by a battery and the connection is disconnected. A dielectric is inserted between the plates of the capacitor. Explain the effect of the dielectric on the capacitance and also the energy stored in the capacitor. So there's one keyword here you need to notice, that the battery is disconnected, which refers that the charge inside the capacitor is conserved. So when the dielectric is inserted in the capacitor, so we know that the dielectric will be polarized and produce a reverse electric field, which is opposite to the direction of the electric field between the plates of the capacitor. So this would reduce the resulting electric field and also the potential difference between the capacitor. And based on the equations of Q equal to CV, capacitance is increased when the potential difference across the capacitor decreases, given that the battery is disconnected and the charge in the capacitor is conserved. So for the energy stored, we have the formula of half Q squared over C, because charge is conserved, so we have to use this formula. So if the charge is maintained, when the capacitance increases, energy is decreased. On the other hand, if the voltage is maintained, which means the battery is still connected, we'll use the formula of half CV squared. When the capacitance increases, we will have more energy can be stored in the capacitor. But for this case, the battery is disconnected, so only can, based on these equations, that the energy is decreased when the capacitance increases. We move on to question 19. Based on the motion of free electrons, describe the mechanism of electrical conduction in the metal and also the heating effect in the metal conductor. So first of all, the electron is in random motion and have zero mean velocity. So what causes the electrical conduction is that when the potential difference is applied on the metal conductor, so we learned that the electron has a drift velocity. Electron is drifted towards to the higher potential of the conductor, which constitutes an electrical current. As for the heating effect, so we know that electron is constantly colliding with the ions of the metal. But when they are in random motion, they have zero mean velocity. So if the potential difference is applied, it collides with the ion at a constant rate and transfer the kinetic energy into the heat energy that causes the temperature increase in the metal conductor. So now we move on to the next question. Show that the current density J equal to sigma E is equivalent to Ohm's law, where sigma is the electrical conductivity and E is the electric field strength. So this is something you have learned in the syllabus. So we're going to find the relationship between the J equal to sigma E with the Ohm's law, which is the V equal to IR. So let us do revision on these derivations. So first of all, what I can suggest is that you can find out the relationship between each of the variable. So we can see that the J can be related to I, where the J is equal to I over A. And then for the sigma, it is related to the resistance, that is the reciprocal of resistivity. And you also learn about the electric field strength as the ratio of the potential difference to the separation distance, and we'll use L for this case. And now we're going to rearrange the equations. Then we have the V is equal to the current multiply rho L over A. So current multiply rho L over A. So if you remember the formula of the resistance, it is a rho L over A. So from here, we can prove that the J equal to sigma E is related to the Ohm's law. So I would say that the 5 marks is quite generous if you know how to do the proving. And proceed to question C. A potential difference of 0.3 volt is applied across the wire of length 1.1 meter and cross-sectional area of 1.5 times 10 to the power of -6 meters squared. The wire carries a current of 4 ampere and the density of free electron is 1.4 times 10 to the power of 29 per meter cube. Determine the mean time between the collision of the free electron. So a lot of information are given and probably you are clueless on what formula are going to be used. So the mean time between collision is appear in the formula of the electrical conductivity that we have learned in the syllabus. So you need to recall the formula of the sigma, and we can do the revision here. So first of all, what we can do is we relate the current density as NVE equal to sigma E. And from the video of the roadmap that I have presented before, so what we have is going to derive the formula of electric field strength and express it in terms of the drift velocity. So what we have is the electric field strength is the F equal to QE, where we have Fe is equal to F over E. And then we have the force is equal to MA, so we have MA over E. And then we have the expression as the formula of VT, so we have MVT over E. And then the next thing that we're going to do is going to substitute the formula of the electric field strength into the equation above. So what we have is NVE is equal to sigma multiply NVT over E. And when you rearrange the equations, you should obtain that the conductivity is equal to NE squared T over the mass. So now let us review what are the information given. So first we have the potential difference and the length of the wire. So this can give us the value of the electric field strength. And then we have the area and also the current. So this will give us the current density. So and then we have the electron density. So if you notice that we need the electron density and we have the charge of electron and the mass of electrons. So now we have all the information ready to put into the formula. So we're going to rearrange on what are the information that we have gathered. So first of all, that the current density is equal to the I over A, which are given in the questions. And for the formula of the conductivity that we have derived, which is equal to NE squared T over M. And then we have the electric field strength as the ratio of the voltage to the length of the conductor. So now you can use this formula to determine the mean time between the collisions. And let us do the calculations. So you can do it on your own pace. So I will do it on my own. So we have the current divided by area, 4 divided by the area, which is 1.5 times 10 to the power of -6. And then what we're going to do is multiply the mass of the electron and also the length of the conductor, 1.1 meter. And then we're going to divide by the electron density, which is 1.4 times 10 to the power of 29. Divide by the charge of the electron, square, and then divide by the voltage, which is 0.3 volt. So final answer should be equal to 2.48 times 10 to the power of -15. So this is how we can solve this question. So I suggest you to improve on derivations because if we have this question with 6 marks, I think this is easy to get more marks in the exam. So let's proceed to question 20. Battery, resistor, and a variable resistor and ammeter, also the voltmeter are connected as shown in the circuit. So first is to explain with the aid of a graph, the variation of terminal potential difference with the current when R is increased gradually. And then we're going to state how the value of the internal resistance and also the EMF can be determined from the graph. So this is something about the internal resistance. So first of all, we have the formula of V equal to -IR plus E. And from the circuit above, so we can identify that the current is equal to the voltage divided by S plus R, or we can also use the EMF divided by the total resistance, which is include the internal resistance. So this should be the graph that you can draw. So when R is increased gradually. So based on the second equation, we can expect that the current is also decreasing. So terminal potential difference is also reduced linearly due to the voltage drop across the internal resistance of the battery. And this is based on the first equations. So in conclusion, we need to relate the terminal potential and the current. So the terminal potential difference is reduced linearly with the current in the circuit. So I think this should give you the full mark, but if you still have any other idea to add in, you can leave it in the comment section. So second question is to state how the internal resistance and the EMF can be obtained. So simple. So internal resistance is the negative of the gradient of the graph. And the EMF can be obtained by the y-intercept of the graph. And then we're going to proceed to the next question. Four resistors R1, R2, R3, and R4 are connected to a battery of 12 volt with internal resistance of 1.5 ohm as shown in the circuit. So the resistance are 10, 5, 15, and 10 ohm respectively. First is to calculate the potential difference between K and L, and then we're going to determine the power supply by the battery. So let us look at the first two questions first. So what we can do is we can treat the circuit above as something like this. So to calculate the potential difference between K and L, so what we can do is we can find out the voltage between L and N. So to do that, maybe we need to get the effective resistance between L and N, that the 10 and 10 is in series, and then 5 and 15 are in series, and then both of them are connected in parallel. So the calculation is here, so you should get the value of 10 ohm. And then what we can do next is to apply the potential divider to obtain the voltage of Ln. And then we're going to apply the potential divider again between 10 and 10 ohm. So what I mean is that we can obtain the voltage of Lk by the potential difference between 10 and the 10 plus 10 ohm. Multiply the voltage of Ln. And then the voltage across Ln also can be obtained by the potential divider again between the effective resistance and the total resistance. So what we have is the effective resistance is also 10 ohm. Divide by 10 plus the internal resistance, which is 1.5 ohm, which is that in the equations. Multiply the EMF of the battery. So now just key in the value and should obtain the answer. So 10 divided by 20. Multiply 10 divided by 11.5. Multiply 12. And you should obtain the answer as 5.21 watt. So it should be 5.22 watt. And then next is to determine the power which is supplied by the battery. So I'm not sure why this question can give you 4 marks, but the power supplied by the battery can be calculated by the formula of power equal to V square of R. Okay, where the voltage is the voltage across all the resistors, so it is 12 volts, divided by the total resistor, which is 10 plus 1.5 ohm. So just key in the value 12 square divided by 11.5. And the answer is 12.521. So if you think there's a mistake in my solution, you can tell me in the comment section. And we just proceed to question 3. If R is replaced by an unknown resistor, determine the value of R so that the potential difference between K and M is 0. So this is something that is similar as the Wheatstone bridge. Then we can actually apply the formula of the Wheatstone bridge. When the R1 is replaced by an unknown resistor, so what we know is when we have a 0 potential difference, so something like happened in the Wheatstone bridge that the proportional of the resistance is equal. So what we have is the ratio of the Rx to the resistance of 10 ohm should be equal to the resistance of 5 to 15. And from here, what we can do is the resistance of Rx should be equal to 1 over 3 times 10, which is 3.33 ohm. So that should be the resistance of Rx. So that's all for the past year discussion, and this will be the last for the year 2022. If you still have any questions, you can leave it in the comment section, or you can post your group in the Telegram channel. And that's all for the Physics Term 2 2022. Thank you for support, and thank you for watching.